This is the solution video for section 8.2, problem number 9. All right, so in section 8.2, problem number 9, the directions tell us, it says for problems 7 through 11, the region R is bounded by the graphs of the given equations. Set up an integral for the volume of the solid generated when R is revolved about the given axis. All right, so this is a setup only problem. Right? So you want to make sure that you're not doing too much work here. All right, so first of all, we have to come up with a graph. All right, y squared equals x. What is y squared equals x? All right, you could think about this as y squared equals x, so it's a sideways parabola, or you could square root and get y equals plus or minus root x. Well, of course, sideways parabola, right? But the positive is the top half and the negative is the bottom half, right? So you do have to make sure you realize it is the full sideways parabola. All right, what about 2y equals x? Well, 2y equals x is a line, but you might want to rewrite it as y equals 1/2 x, right? Which is a line with a slope of 1/2, y-intercept of 0, 0. So something like this, right? So now, what we actually have is this small little region here, right? Now, we are revolving this about the y-axis, right? So we're revolving about the y-axis. All right, so key is that we have to remember that when we are revolving about the y-axis, right, we want the cut to be perpendicular to the axis of rotation. All right, so the cut needs to be horizontal, right? So this is a dy cut because that is perpendicular to the y-axis. All right, so now, if I have a dy cut, I want my equations in x equals form, which they are, or they were to begin with, right? All right, so I have x equals y squared and x equals 2y. All right, so now, all right, I need to know the points of intersection. Well, the first point of intersection is 0, 0, right? That's easy because we figured that from graphing. But how do we determine this? Well, I set y squared equal to 2y, right? The two equations are equal. All right, so this is a relatively easy equation. Y squared minus 2y equals 0. And so I factor out a y, so I get y minus 2. So y equals 0 or 2. So that's actually pretty easy. So this point is 0, 0. That was easy to begin with. And this point is something, comma 2, right? So if y is 2, then 2 times 2 is x, right? So that would be 4. All right, so 4, 2. So then you'd want to make sure that 4 is equal to 2 squared. Yes. All right, so that is my, there's my graph. All right, so now we know that we want to use the washer method as opposed to the disk method because there is a gap. Remember, this is a gap between the axis of rotation and the region, right? And so we have to use the washer method and not the disk. All right, so that means washer method. All right, so remember, we start off with pi times the integral of big parentheses with respect to, well, in this case, y. All right, then I have little parentheses squared minus little parentheses squared. All right, so that's the setup for the washer method, remember. All right, so now I have the first set of parentheses, the big R, right? So that is the distance that the further boundary is from the axis of rotation. So how do I find the distance that this line is from the axis of rotation? I take the right-hand thing, which is the line, so that would be 2y, and I subtract the left-hand thing, which is the axis of rotation, which is 0, right? And then I'm squaring that. Minus, all right, now the nearer boundary of the region to the axis of rotation, so that would be the curve, which is the y squared. So we're going to take y squared and subtract the axis of rotation, which is 0. All right, so now that is my integrand. All right, and so now I'm integrating from what to what. So remember, this is an integral with respect to y, so that means our limits need to be y values. So the lowest y value is 0, and the highest y value is 2. All right, so now this is probably not what you see in the answer sheet because you'd be looking for something like pi times the integral from 0 to 2 of, and I would simplify this as 2y squared, or maybe 4y squared, minus y squared squared with respect to y, or you could see y to the 4th. So the other variation would be pi times the integral from 0 to 2 of 4y squared minus y to the 4th, with respect to y. So you got to remember you're looking for all maybe these different variations on the answer sheet.